if you want to derive the amortisation of a loan formula, just have a look at, it's 2017, I think it's question 8 maybe. And the very first thing that they asked you to do was to derive this formula. Now, I didn't take it down exactly, but this is the idea of what you were given in the question. So you have a loan of P amount, whatever, 30,000, I haven't a clue, is repaid in equal amounts, they called A, at the end of each T, your time period, equal periods of time, where I is the compound interest rate, and it says I is the interest rate written as a decimal. And what else does it say? It just says, you can use your sum of a geometric, I think, to derive this formula. So I took it down quickly there, so I don't even think I took it down very well as to exactly how it's written in your log tables. There it is. So they've used all the letters that are in your log tables. A equals P, and then you have your fraction I, 1 plus I to the power T, and then we have 1 plus I to the power T minus 1. Excuse me. So at least I know where I'm going. This is great if you want to brush up on your basic algebra. So I'm going to have a separate sheet here for my rough work, because I'm going to have to be able to add fractions, subtract fractions, multiply, divide, etc. Get two fractions into one single fraction. So over here, I'm going to write my rough work. I don't want a big mess here in the middle. And I need to start off. So this is where I'm going to end up. So at the bottom of my page, I'll eventually get to this point here where A equals P I 1 plus I to the power T all over 1 plus I to the power T minus a 1. This is where I'm going to end up, on the bottom of my page. How do I start off? Well, I'd like you to think of any loan. When do you get your money? You get the money straight away. So we get what we call P in this question straight away. So maybe you'd like to think about this with regards to an actual loan. So you get 30,000 straight away, and then that's equal to all the repayments that you have to make over a certain time frame, let's say 10 years, doesn't matter. And we need to figure out what X is, how much we're paying back, but you cannot add things in different time frames, so you need to have them all in the same time frame. The easiest time frame, I feel, is right here now with this 30,000. So this is 1 month into the future, whatever it is. This is 2 months into the future, and so on up until, let's say, 10 years into the future, which is 120 months. Well, maybe you'd like to have this somewhere for yourself, because some people, it's harder to work in abstract. So 30,000 is the amount of the loan. What have they called the amount of the loan? They've called a P. And that's equal to, I've called X the amount that I'm repaying, but A is what they've called it. And I'm going to just put it straight into what I already know, that the money has to all be in the same time frame. So that's 1 plus I to the power 1 to the power of time is T for them. And this is my very first line. Hopefully you feel happy enough creating that. And all that you have to do now is take this line, carefully work with it, carefully use your algebra. That's pretty much it. It's all just algebra, because at the minute the P is isolated. But if you look at your formula, we want the A to be isolated. So that's all you're doing. Take your time, work with the right, clean it up, and eventually isolate the A, and it will look like this. So this is nothing but from here on, this is nothing but an algebra question. Okay, can you move it around so that you can find what you're doing? So coming up with that first line, I'm hoping, is actually maybe it won't even be that difficult. I don't know. I'm hoping you're not going to find the algebra the difficult part. So what am I going to do? I'm going to straight away take the A out in common. I'm left with 1 all over I to the power 1 plus 1 all over I to the power 2 dot 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 plus 1 all over 1 plus I to the power t. I'm going to sum this up. Okay, it's a geometric. All of these are geometrics because they're compound interest. So P is equal to A bracket. Now, so I'm summing up my formula. Okay, so I have my P, I have my A, and I'm going to sum up this bit here using my summing up formula. Okay, so we have how many terms? We have t terms. So this is going to become a t. R is your common ratio. So it's any term. So I'm going to get my common ratio over here in my rough work. So common ratio is any term divided by the one before it. Hopefully your algebra is good enough that you realise that division is the same as multiplication, but invert your fraction. Multiplied by 1 plus I over 1. And so the top is 1 bracket 1 plus I, and the bottom is 1 plus I by 1 plus I by a 1. I hope you're understanding what I'm doing there. And then these cancel off, and all I end up with is 1 all over 1 plus I. So there's my common ratio. Okay, so when I go back over here, that's my common ratio there, 1 all over 1 plus I. A is my first term. Oh, it actually just so happens that my common ratio and my first term are the same thing. Anyway, so P is equal to A bracket. So it's my first term. 1 minus my common ratio to the power of t all over 1 minus my common ratio. If you need to, stop the video, go back, make sure you're happy with every step that I took there. Now, this needs to be cleaned up. So I'm going to take these two, so two fractions, get it into one single fraction. I'm going to do that over here in my rough work section. So look at my bottom line. Was that 1 over 1 is that. I'm going to get my common ratio, my common denominator. 1 goes in there, 1 plus I times my top number. Whatever way you do this, it's second year stuff, I think, where you're adding fractions. So that goes in there once, 1 times my top number. And I end up with 1 plus I minus a 1 all over 1 plus I. They cancel off. I end up with that. Back over here. All over I all over 1 plus I. There is so many ways to continue from here. I'm going to rewrite this. You know, if you have something divided by something else, that's the same as something multiplied by the inversion of this inverted. So that's what I'm going to do. I'm going to go over here to the side. So I'm taking my top line. Now, if you did all of this here, you'd have a big mess. So for me, it's important to have rough work. Right, so this is being all of that. There's my top line, and it's divided by I all over 1 plus I. But that's the same as your top line multiplied by this inverted. Okay, so we have this by this by this. And look what happens. Okay. So now you'd have to show them your rough work. You have to hand up every single piece of paper anyway. I now have P is equal to a bracket, and I no longer have all of this. I have, you know, top by top, bottom by bottom, and I end up with 1 minus 1 all over 1 plus I to the power of T all over I. So I've cleaned that up a good bit. It's still not perfect, but I'm getting there. Again, stop the video if you need to and go back and have a look. Now come my rules of indices. Because there's an indices there, I'm going to open this and just see if there's any rule that I can use that might make this look a bit nicer. Now just this bit here is what I'm focusing in on. So again, I'm going back over to my rough work here, and I want to focus in on just this little bit here. Just see if I can make it look a bit nicer. So you go to your log tables. Is there any rule there? Yep, look at that one. If you have a fraction to a power, you can put each one to that power. So I have 1 to the power of t. Well, what's 1 to the power of 5? What's 1 to the power of 20? What's 1 to the power of a million? What's 1 to the power of t? 1. Going back here, and I can see that I now have P equals a bracket 1 minus, I've in my rough work section, I have cleaned that up to look like this. Over I. Doesn't matter, I guess. I might write that a little bit cleaner. So I'm going to rewrite that there, top of this page, just a little bit cleaner. So same line, haven't done anything now. So we're number 1 there if you want. So even if you wanted to, you could just go P all over I. Is that okay? because if you go top by top, bottom by bottom, I'm going to bring that I over here. And the reason that I'm doing that is when you eventually look at what you're looking for, there's an I nearest to the P, pretty near to the P. So I'm going to bring this over. Remember, what am I trying to do? I'm just trying to isolate the A. Clean up as much as possible and isolate the A. Okay, I still haven't got this cleaned up. I have two fractions. I want to get it into one single fraction. Off I go over here again to my rough work area, and I have just that little bit, 1 over 1 minus 1 all over 1 plus I to the power t. Get it into one single fraction. Common denominator. That goes in here, 1 plus I to the power t times my top number, minus that goes in there once. And that is equal to 1 plus I to the power t minus a 1 all over 1 plus I to the power t. So what have I cleaned up? Over here in my rough work section, I've now cleaned this bit up here. So I have P by I is equal to a bracket, and instead of this, I'm going to put in what I've cleaned it up to be as one single fraction. Okay. And I think now it's just time to isolate the A. So this goes over and becomes multiply. So P by I by 1 plus I to the power t. And this goes over and becomes division. That okay? And then this is what I'm looking for. So I have the A on the right, so I'm going to move it over to the left. And then that's it. So the P, they've just written out here, so that's, P over 1. The I times this is my top line, and there's my bottom. Now I'm sure you could do it in much faster steps than me. Maybe you don't need as much rough work as I did, but I just wanted to do it out as clearly as possible. So what did I need in there? I needed to be able to have my first line in terms of the letters that they've used. I needed to be able to use my SN formula of a geometric. Then I needed to be able to get two fractions into one single fraction. Then I needed to be able to do division of fractions. Then I needed to be able to use my indices rules. Then I needed to be able to get two fractions into one single fraction. And from there, I just isolated the A.